You hear the word sloth, you probably picture a creature that feels like a biological mistake. You picture a slow-moving, moss-covered, perpetually tired animal hanging upside down in a tropical rainforest, sleeping for up to 20 hours a day. They move at a top speed of maybe 1 mile per hour, their fur is often tinted green from symbiotic algae growing inside the hair shafts, and they are so lethargic that entire colonies of moths live and breed inside their coats. They look like an evolutionary joke, a fragile creature surviving purely by accident in the canopy, hoping predators simply don't notice them. A sloth always looked simple to me, just a slow mammal trying not to be eaten. But once I actually started digging into the evolutionary history of the sloth, everything changed. I didn't expect to find a lineage of creatures this over-engineered, this colossal, and this genuinely terrifying. Looking at a modern tree sloth and judging its ancestors is a massive evolutionary illusion. It is like looking at a tiny, harmless house cat and trying to understand the biomechanics of a saber-toothed tiger. Because for millions of years, the sloth wasn't a fragile, leaf-eating tree hugger. It was a titan, a 4-ton, 20-foot-tall biological tank that literally looked over the roofs of modern 2-story houses. It didn't hide from predators. It crushed them. It didn't gently pick leaves. It ripped entire trees out of the ground with its bare hands. This is the story of Megatherium, the giant ground sloth. A creature so massive, so heavily armored, and so completely over-engineered that it rewrites our understanding of prehistoric survival. To understand how truly bizarre this animal was, we have to look inside a body plan that breaks almost every rule of modern mammalian biology and go back to a world that is barely recognizable as our Earth. To understand the giant ground sloth, we have to travel back in time over 30 million years to the Oligocene epoch. At this time in Earth's history, South America was an isolated island continent. It was completely cut off from North America, Africa, and the rest of the world by vast, impassable oceans. Because of this extreme geographic isolation, the animals trapped on this continent evolved in a completely different direction from the rest of the planet. There were no horses, no bears, no wolves, no elephants, and no modern cats. Instead, South America became a floating laboratory for bizarre evolutionary experiments. The landscape was dominated by terrifying marsupial predators, giant flightless terror birds equipped with axe-like beaks, and a strange ancient lineage of mammals known as the xenarthrans. The xenarthrans are a superorder of mammals that includes modern armadillos, anteaters, and sloths. The name Xenarthra literally translates to strange joints, and this name hints at the first bizarre adaptation of the giant ground sloth. While almost every other mammal on Earth, including humans, has a standard set of articulations in their lower back vertebrae that allow for flexibility, the xenarthrans developed extra interlocking joints. These strange joints locked their lower spines into a rigid, incredibly powerful structure. What they sacrificed in flexibility and speed, they gained in sheer, uncompromising physical strength. They were built like living bulldozers. And among these ancient pioneers were the ancestors of Megatherium. They started relatively small, but over millions of years of evolutionary arms races with the terrifying predators of South America, they began to grow. They grew until they became the undisputed kings of the continent. When we talk about the size of Megatherium, it is difficult to wrap your mind around the sheer scale of the animal. If you stood a fully grown Megatherium next to a modern adult male African elephant, they would look each other right in the eye. Stretching up to 20 feet from the tip of its snout to the end of its massive tail, and weighing an estimated 4,000 kilograms, or nearly 9,000 pounds, this was one of the largest land mammals to ever walk the earth. But what makes Megatherium fascinating isn't just its immense bulk. It is the terrifying weaponry it carried and the bizarre biomechanics required to move that weaponry around. Its forelimbs were equipped with claws that were over a foot long. These weren't just elongated fingernails, they were massive curved scythes made of incredibly dense bone, originally covered in a thick, razor-sharp keratin sheath. A single swipe from an arm wielding these claws carried enough kinetic energy and piercing power to cave in the skull of the largest predators or snap the spine of a massive dire wolf instantly. But having foot-long swords for fingers creates a massive evolutionary problem. How do you walk? You can't put your palms flat on the ground without snapping your own claws or shattering your wrists under 4 tons of crushing gravitational weight. Evolution had to engineer a radical solution. Megatherium developed one of the most bizarre walking styles in the animal kingdom, known as a pedolateral stance. Instead of walking on the soles of its feet like a bear or a human, or walking on its toes like a dog or a horse, the giant ground sloth literally walked on the sides of its feet and the knuckles of its hands. It curled its massive claws inward, protecting them from the hard ground, and rested its entire immense body weight on the outer edges of its foot bones. If a human, or almost any other mammal, tried to walk like this, the bones in our ankles and feet would shatter into splinters under our own weight in seconds. But the sloth's skeletal system underwent extreme modification. The bones in their feet and ankles thickened, fused, and reshaped themselves into massive, dense pillars of calcium designed specifically to support this unnatural load. It was a slow, lumbering, knuckle-walking gait, resembling the movement of a modern gorilla but scaled up to the size of a dinosaur. Megatherium couldn't sprint. It couldn't outrun anything. But as we look deeper into its anatomy, we realize that Megatherium didn't need to be fast, because it had a secret defense mechanism that made running completely unnecessary. Imagine the Pleistocene epoch, the height of the Ice Age. The North and South American continents have finally collided, creating the Isthmus of Panama. This geological event triggered the Great American Biotic Interchange, a biological war where northern predators flooded into South America. The landscape was suddenly swarming with hyperpredators. The Smilodon, the infamous saber-toothed cat, stalked the plains. These cats were apex killers, equipped with 8-inch canine teeth designed to slice through thick hide and sever vital arteries in a matter of seconds. So, what happens when a pack of saber-toothed cats lunges at a slow-moving, lumbering, 4-ton sloth? Logically, it should be an easy kill. But when the predator's jaws clamped down, they didn't sink into soft flesh. They hit a biological brick wall. The predator's teeth would stop dead, risking shattering upon impact. This is because beneath its thick, shaggy fur, Megatherium was wearing hidden biological chainmail. When scientists first began analyzing the fossilized skin of giant ground sloths, they discovered something that shocked the paleontological world. The skin was packed with thousands of small pebble-like bones called osteoderms. These bones were embedded directly into the dermal layer, interlocking to form a flexible but nearly impenetrable shield. It is the exact same biological concept used by modern crocodiles, ankylosaurs, and armadillos. But on the giant ground sloth, this armor was completely hidden from sight. To a predator, Megatherium just looked like a giant, soft, furry animal. It was an evolutionary trap. If a saber-toothed cat actually managed to leap onto the sloth's back and bite down with all its force, its fangs would instantly hit this hidden wall of solid bone. The teeth would deflect, slide, or shatter before they could ever reach the sloth's muscles or vital organs. This is defense designed at a microscopic anatomical level. But Megatherium didn't just rely on passive armor. When pushed, it deployed a terrifying active defense. When a predator threatened a Megatherium, the giant sloth didn't attempt to flee. It stood its ground and did something that must have paralyzed predators with fear. It stood up. Megatherium possessed a tail that was not just a useless appendage, it was essentially a giant, muscular pillar of bone. Using this incredibly thick tail as the third leg of a tripod, Megatherium would shift its center of gravity and rear up entirely on its massive hind legs. Suddenly, this slow-moving, quadrupedal animal transformed into a towering giant, reaching heights of over 15 feet in the air. From this bipedal stance, it looked down upon its attackers. More importantly, this posture completely freed its massive, muscular front limbs. With its foot-long claws raised and ready to strike, the sloth became a fortress of muscle and bone. One downward swipe from those arms could literally crush a predator into the earth. It was a defensive posture so visually intimidating and physically lethal that an adult Megatherium essentially lived a life completely free of natural predators. It was the undisputed heavyweight champion of the Pleistocene plains. Despite looking like a monster out of a prehistoric nightmare, Megatherium was, at its core, a gentle giant. It was a strict herbivore, moving slowly across the landscape, looking for food. But because of its massive size, it didn't just passively exist within its ecosystem, it actively engineered it. Unlike modern grazing animals like cows or horses, which have highly specialized teeth coated in thick enamel to continuously grind down tough, abrasive grasses, the Xenarthrans took a completely different, almost counterintuitive evolutionary approach. They had terrible teeth. In fact, their teeth lacked enamel almost entirely. Their teeth were made of soft dentin that constantly wore away and grew back continuously throughout their entire lives. So how does an animal the size of an elephant process enough tough, fibrous plant matter to fuel a 4-ton body without properly chewing its food? The answer lies in its massive, highly specialized digestive tract and the power of extreme fermentation. Megatherium possessed a stomach and hindgut that functioned like a massive biological brewery. It didn't need to chew its food into a fine paste. It used its long, prehensile tongue and its massive claws to pull down entire tree branches, stripping them of leaves, twigs, and fruits, and swallowing huge quantities of this tough, fibrous matter largely unchewed. Once inside its enormous gut, millions of symbiotic bacteria and microorganisms went to work. The digestion process was incredibly slow, taking days or even weeks for food to pass entirely through its system. But this slow process was fiercely efficient. It extracted every possible nutrient from food that other animals couldn't digest. Furthermore, because their metabolic rate was significantly lower than other mammals of a similar size, they operated on a low energy budget. They didn't need to eat constantly. This low metabolism, combined with their incredible digestive efficiency, allowed them to survive harsh droughts, famines, and bitter Ice Age winters that starved other, more highly strung megafauna to death. They were ultimate survivalists, slowly marching through an ever-changing world. And their bizarre digestive system left behind an ecological legacy that you still interact with today. If you look closely at modern plants, you will find evolutionary ghost traits that make absolutely no sense in the modern world, until you realize they were shaped by the giant ground sloth. Have you ever cut open an avocado and wondered why the seed is the size of a golf ball? Think about the fundamental purpose of fruit in nature. A tree produces sweet, fleshy fruit to entice an animal to eat it. The goal is for the animal to swallow the fruit whole, walk several miles away, and pass the seed in its droppings, effectively planting a new tree in a pile of ready-made fertilizer. But look at the animals alive in the Americas today. There is nothing alive that can swallow an avocado whole and pass that massive seed through its digestive tract without dying. The avocado seems like a plant destined for extinction, unable to spread its seeds. That is, until you realize that avocados evolved specifically to be eaten by Megatherium and its relatives. A giant ground sloth could easily swallow dozens of avocados whole. The massive seeds would pass harmlessly through its enormous digestive tract, and days later, the sloth would deposit them miles away. The avocado, the Joshua tree, the Osage orange, and trees with massive, terrifying thorns designed to defend against giant browsing herbivores, these are all evolutionary ghosts. The sloths that shaped them have been gone for 10,000 years, but the plants are still here, unknowingly waiting for the ghosts of the Pleistocene to return and eat their fruit. For millions of years, the giant ground sloth was seemingly invincible. They survived the shifting of tectonic plates, they survived massive volcanic winters, they survived multiple sweeping ice ages, and they survived the terrifying invasion of the saber-toothed cats during the Great American Biotic Interchange. Some species of giant ground sloth even marched north, crossing the newly formed land bridge into North America, adapting to freezing temperatures and spreading all the way up into the frigid environments of the Yukon in Canada. They successfully colonized an entirely new hemisphere. They were adaptable, heavily armored, and nearly impossible to kill. But then, around 10 to 12,000 years ago, they met a predator they couldn't ignore. A predator that didn't play by the biological rules of the Pleistocene. They met us. Early humans had crossed the Bering Land Bridge and were rapidly expanding across the Americas. For a long time, scientists debated how humans and giant sloths interacted. Were sloths just slow, dim-witted targets that early humans easily slaughtered? The fossil record recently revealed a story that reads like a high-stakes prehistoric thriller. At White Sands National Park in New Mexico, scientists uncovered a series of fossilized footprints preserved perfectly in gypsum mud. These footprints capture a fleeting moment in time from over 10,000 years ago, detailing a life-or-death battle between humans and a giant ground sloth. The tracks show the giant sloth walking in a straight line across the muddy landscape. But directly inside the sloth's massive footprints are the tracks of a human. The human hunter was deliberately stalking the sloth, stepping precisely in the deep indentations left by the giant beast to mask their own approach, hiding their sound and their scent. But the sloth was not a dim-witted, unaware creature. It was hyper-alert. The tracks show a sudden, dramatic shift in behavior. The sloth realizes it is being followed. It stops abruptly. It pivots. The massive, deep indentations in the mud show the sloth rearing up on its hind legs and its massive tail, adopting that terrifying bipedal defensive stance. The tracks show the sloth spinning in a tight circle, sweeping its massive, lethal claws in a defensive arc. The human tracks suddenly scatter, showing the hunter rapidly backpedaling, dodging and weaving just inches from the swinging blades of bone. Then, another set of human tracks approaches the sloth from the opposite direction. It wasn't a lone hunter. It was a highly coordinated tactical pack ambush. Humans were using their intelligence to distract the giant from one side while attacking from the other. We don't know the outcome of that specific battle frozen in the mud. We don't know if the hunters brought the giant down or if the sloth crushed its attackers. But those footprints prove one undeniable fact. Hunting a giant ground sloth was not a simple, easy slaughter. It was a terrifying, high-stakes war against a hyper-aware, highly dangerous 4-ton titan. Ultimately, right around the end of the Pleistocene epoch, Megatherium and almost all of the giant ground sloths vanished from the face of the Earth almost overnight in geological terms. The exact cause of their extinction is still a subject of intense scientific debate, but it was likely a devastating combination of factors. The climate was rapidly warming, glaciers were retreating, and the lush, expansive environments the sloths relied upon were shifting and shrinking, drastically reducing their food supply. But climate change alone had never killed them before. The deciding factor was almost certainly human pressure. Humans possessed advanced projectile weapons, like the atlatl, which could launch a beautifully napped flint Clovis point with enough penetrating force to bypass the sloth's hidden bone armor. Humans used fire to alter landscapes and drive animals into traps. Most importantly, humans hunted in coordinated packs. Because of the sloth's slow metabolism and long gestation periods, they reproduced incredibly slowly. They simply couldn't replace the individuals that were being hunted fast enough to sustain their populations. The ultimate survivors of the Ice Age were finally outmaneuvered by the ultimate apex predator. But evolution is a continuous, unbroken chain. The extinction of Megatherium is tragic, but it is not the end of the story. The sloth lineage did not fail. The surviving sloths we see today, hanging slowly in the rainforest canopies of Central and South America, are not the weak, pathetic remnants of a dying family. They are, in fact, extreme evolutionary specialists. Faced with the pressure of human hunters, changing climates, and fast-moving ground predators, the ancestors of the modern tree sloth made a radical evolutionary choice. They didn't try to fight. Instead, they shrank down in size. They slowed their metabolism down to an absolute crawl, making them require very little food to survive. And they abandoned the ground entirely, climbing high up into the dense, inaccessible canopy of the rainforest. They allowed algae to grow in their fur to act as natural camouflage against the green leaves. They became so slow and so quiet that predators simply couldn't see or hear them. The modern tree sloth survived the apocalypse that wiped out its giant cousins by becoming invisible. The story of the giant ground sloth proves that nature isn't normal. It is an endless, bizarre, and terrifying experiment. It proves that life will build whatever it takes to survive, whether that means engineering a 4-ton biological tank covered in hidden armor and wielding foot-long swords, or engineering a tiny, slow-moving creature that hides perfectly in the leaves. If you want to keep exploring the weirdest, most terrifying, and over-engineered creatures evolution ever created, make sure to subscribe. And if you enjoyed this journey into the deep past, you definitely want to click the video on screen right now, where we break down why the T-Rex was actually far stranger, far smarter, and far more terrifying than Jurassic Park ever showed you. I'll see you there.